This video is on the objective identifying the null and alternative hypotheses. This is number one, the first video on a question related to this objective. Alright, so I'm going to take you through just that step in hypothesis testing where you have a claim that is made about a parameter from the population, and based on that claim you form two hypotheses, right? This null hypothesis and alternative hypothesis that you will then test. So let's see how that's done. All right, so you're forming hypotheses. So again, first some sort of claim is made about a parameter, like mu or p, right? The population mean or the population proportion or something else. I mean, we'll see hypothesis tests later on down the road that are about other things besides means and proportions. All right, and then from this claim we form hypotheses. Well, it should be an ES, but hypotheses. The first of these is called the null hypothesis, or H0, H sub 0. Now, something about interesting about the null hypothesis, something you should always keep in mind, is that it always involves equality in some way. Either the null hypothesis can look like one of three things. Now, in this book, right, in this Newton Alta, it's only going to be one thing. But just know that it could take on these other two forms if you're looking at other books or you're looking up something else online about this, or just know that it always involves equality though. So either the parameter equals some value, or it could look like this: the parameter is greater than or equal to some value. Or it could look like this: the parameter, mu or p, is less than or equal to some value. But either way it looks, it has equality involved in some way. And when you actually perform a hypothesis test, a test of a claim, what we're going to be assuming is true is the equality part. When we go through and test a claim, we're going to be assuming that the value of the parameter is equal to some specified value, and then take a sample and see how it compares. Like we'll go into all those steps in other videos, coming up later. But for right now, stick to the equals, right? So the null hypothesis will be what we're going to be assuming is true, that the parameter is equal to some value. Again, just know that it could take on these other forms: greater than or equal to, less than or equal to. All right, then the opposite of this, right? The contradictory statement to the null hypothesis is the alternative. There should be I had to squeeze an N in there. I'm sorry. That's alternative hypothesis, and this is usually symbolized HA, H sub A, or again in other books, other things I've seen, it's H1. And this is contradictory to the null hypothesis, to H0. So if the null hypothesis will always involve equality, the alternative hypothesis doesn't involve equality. So you shouldn't have an equals or a greater than or equal to or less than or equal to. You have the opposite of those things. So the alternative hypothesis could look like one of the following: either that the parameter is not equal to some value. Right now, being not equal means you can be on either side. And if the alternative hypothesis looks like this, then you're performing what's called a two-tailed test, right? Because you can be on either side of the specified value, right or left. Or the alternative hypothesis could look like this: the parameter mu or p or whatever is greater than some specified value. Right now, being greater than means being to the right on a number line, right? So if your alternative hypothesis looks like this, then they say that you're performing a right-tailed test. Or it could look like this. The parameter in question is less than some specified value. Less than being on a number line would be left of, right? So if your alternative hypothesis looks like this, then they say you're performing a left-tailed test. All right. Now, the claim I mentioned earlier will be represented by either the null hypothesis or the alternative hypothesis. If the claim involves equality, like mu equals 5 or p is greater than or equal to 7.7, if the claim involves equality, then the claim will be represented by the null hypothesis. If the claim does not involve equality, right, is not equal or is less than or is greater than, then the claim will be represented by the alternative hypothesis. All right, but the claim will be represented by one of these two hypothesis statements. All right, so let's get into the question at hand. Right? Let's go to the assignment question related to this objective. So here a brokerage firm is curious about the proportion, right? So like population proportion would be P or something, right? P. So a brokerage firm is curious about the proportion of clients who have high-risk stocks in their stock portfolio. Let the proportion of clients who have high-risk stocks be P, right? The proportion of all clients, right? The population proportion that have high-risk stocks. If the brokerage firm wants to know if the proportion of clients who have high-risk stocks is less than 15%, what are the null and alternative hypotheses? All right. So I'm going to go to a piece of paper here. So again, P was this proportion of all clients, all their clients that have high-risk stocks. They want to test, right? They want to know if the proportion who have high-risk stocks is less than 15%. So the proportion of people who have high-risk stocks, they want to know if it's less than 0.15 or 15%. Now that could be considered the claim here, right? Maybe someone believes that the proportion of all their clients that have high-risk stocks is less than 15%. All right. Now notice how, again, this doesn't involve equality. There's no or equal to, right? It's strictly less than. So the claim will be HA. It'll be represented by the alternative hypothesis, right? So then when you're forming your hypotheses, that HA is just what the claim is, that P is less than 0.15. And then the null hypothesis, that H0, is the opposite of this. Now, again, in some books, the opposite of less than is greater than or equal. So this would be totally valid. This would be totally valid. But in this text, they're only going to be using the equal part. All right. So P equals 0.15. Because this is what we're going to be assuming when we go and actually perform the test. This is what's going to be assumed to be true, and then we're test to see if that's a good assumption or not, using a sample. All right, so for right now, just know that yes, this is totally perfect, right? They should oppose each other. They should be negations of each other. But for the null hypothesis in this book, right, in Newton Alta, they're just going to write down what's going to be assumed in the hypothesis test, the equal part. Right. So that would be this statement here. See the H0, P equals 0.15, and HA, the alternative hypothesis, is that claim, be P less than 15%. And don't confuse it with mu, right? They said P. Okay, nailed it and all that. So alternative hypothesis is what to be tested. We are testing report of that. Right? Never has a symbol with an equal in it. They talk about all that. All null hypothesis always has a symbol with an equal in it. Okay. And yeah, okay, that's it. That's all you have to do for that kind of question. Hopefully this video helps you with that. I'll put up another one as well. And thank you very much for watching.